Okay, so we're carrying on with polymers. We've got the polymer. Poly means many, many ethenes. So we're going to make a polymer. So you start off with a mono, means one. We're going to start off with monomer. You know it's got a double bond. Remember I said ethene is very important. You should know it. Right, the structure of the polymer. Watch this. Brackets. So these are supposed to be brackets here. It's just gone a bit wrong for some reason. Right, so I'm going to put, watch what I'm going to do. I'm going to draw the monomer. Then what I do in my head, this is all going on my head, and then I remove one of the, there you go. And then I extend, so I've got one there, one I've deleted, and then I draw these. It has to cross the brackets and you stick a little N there. That's the structure of the polymer. Plastic bags, rubbish bins, cling film, insulation for electrical cables, all sorts of stuff. Right, okay. So if you look here, if you look on this one, you've got one carbon atom, two carbon atoms, three carbon atoms. So I've got, how shall I, okay, I'm going to do it here. 1, 2, 3. Right. What I'm going to do is I'm going to put a double bond here. So this is meat, eat, rope. Remember, monkeys eat peanut butter. Meat, eat, rope, butte. That's one carbon atom, 2, 3, and 4 carbon atoms. So this has got 3 carbon atoms, so it will be propene. Why is it ene? Because it's got a double carbon to carbon bond. Now, what's happened is, watch this. Not that. Watch this. This carbon to carbon bond breaks. So I'm going to now delete it. There you go. Then I'm going to draw that. And then I'm going to finish off that carbon atom that's broken. One goes, half goes there, half goes there. And I stick a little N there. That's what they've done. Right? So let me undo that. There you go. So I need to copy this monomer. Let me get this. And I need to copy over to here. So that is the monomer, and it becomes a polymer here. This meat, eat, probe. So the polymer will be called polypropene. There you go. Right, again, this is standard answer. You can say many monomers, small molecules, join up to become a poly. What else happens? The most obvious thing that happens, the double carbon to carbon bond breaks to become a single carbon to carbon bond. And it goes from a many small or short chained monomers to become a long chain polymer. Right, okay. Right. The reasons why polymers do not biodegrade. Remember, biodegrade is the breakdown of the polymer by microorganisms or bacteria. And the reason why is because they are inert. Right, right. Problem with burning, it releases toxic gases or greenhouse gases. And the landfill space is running out or difficult to find, and they are getting filled up the existing ones filling up quickly. There you go. Right, alkenes are an homologous solution. Homologous. Homologous means same. They're part of the same series of. Hydrocarbons are molecules that contain only hydrogen and carbon. Right. How do you separate crude oil? Number one, I think we've done this, in the other ones. Right. You heat the crude oil until it vaporizes. It rises up the fractionating column. I'm going to fractionating column. I'm going to use the short version of that. Fractionating column is warmer at the bottom and cooler at the top. Now what happens? What does happen? Right. As the crude oil rises, it will condense further up and it will condense further up, and what happens? It will condense further up and be collected. It will be collected at different heights. Why? Because the fractions, or the little parts of the crude oil, the fractions, that's what they call it, fractionating column. The fractions have different boiling points. There you go. Done. Right. Remember what we said about alkanes and alkenes. Alkenes. Double carbon to carbon bond, single carbon to carbon bond. Right. I always will say to you, remember this. CnH2n. What that means is, if I've got 5 carbon atoms, I double the number of carbon atoms. I end up with 10 hydrogens. If I've got 3, I'll end up with 6. If I've got 2, I'll end up with 4, and so on. So the general formula for alkanes, That was for alkenes, so this is easy. All you do is you copy it. Did I just do that? I can't believe that. CNH2, and then you add 2. Remember that. It'll be CNH2N plus 2. So 2 characteristics, apart from having the same general formula, they have a trend in physical properties and a similar chemical properties. There you go. How easy was that? Right, now this is going to be balancing. Okay. So look, this here. So these are the reactants and these are the products. Combustion. Whenever you see the word combustion, think of oxygen. And remember, oxygen is something called a diatomic molecule. What does that mean? It means it runs around in pairs or in twos. So I remember it as no. And then group 7 is fluorine, chlorine, bromine, and iodine. And then simply stick a 2 there. It's useful. So I now know oxygen is going to run around in pairs, but they've already given it. This is in future if you've got to balance stuff up. So I've got 3 carbons, 1 carbon. So I'm going to just stick a 3 there. I've got 2 oxygen times 3, which is 6. And I've got 1 oxygen, 7. I've got 2 here, so that doesn't work out. So what I need is, I need to balance them out. What was that? 7 and 2. What if I did 10? 6 and 4. So now I've got 10 oxygens and I can easily balance that out. That's 5. And that's it, the balance out. Because I've got 8 hydrogens. 2 hydrogens here times 4, which is 8. I hope that's not too confusing. Right. Incomplete combustion. Do you know when they use the word incomplete combustion, that means there is a lack of oxygen. There's not enough oxygen. Poisonous gas is formed. It's always going to be carbon monoxide. Why is it poisonous? Because, right, just learn this. It reduces the blood's capacity to carry oxygen around the body. That's it done. Right. Combustion of propane releases gases for by the formula N or something. X can be 2, 3, 4, 5, whatever it is, I think. Yeah. So we know it's got nitrogen in it. And we know it's got oxygen in it. So the nitrogen's from there. The oxygen is from there. There you go. Right. So you've got, what is an isomer? An isomer is a molecule with the same molecular formula, but different structural, or I like to use the word displayed formula, but they're both acceptable. I could have written structural formula. Right, I've got 5 there, so monkeys eat peanut butter. Then after that, remember what I said, 5 is pentane, because a pentagon has 5, hexane, hexagon, and so on. We need to draw isomers. So the easiest one is, I know it's got 5 carbons, so I'll do 1, 2, 3, 4, 5, and I know each carbon has 4 bonds. So look, this is what I've got so far. So what I'm going to do is I'm going to make this carbon at the end have 4 bonds. So you've got 1, 2, 3, and it's already got 1 there, yeah? So hydrogen, hydrogen. Yeah, so I've got 4 bonds on there. Remember, this one is also theirs. The share in it. So this carbon's got 1 so far. 2, 3, 4. Then we can make it 1, 2, 3, 4, and just say stick. These are all hydrogens. Hydrogen, hydrogen, hydrogen. So it'll have the same number of carbons and hydrogen. So these are 2 isomers. An isomer is a molecule with the same molecular formula but different display. Whoa, what happened there? Different displayed formula. There you go. Right. F. Yep, let's run with that. Right, remember what we said about this structure. What you do is you put carbon, hydrogen, oxygen. You put the percentage or the mass here on the first line. So in this case, you've got 53.3, 11.1, and 35.6. So look, I've simply picked them up. That's my structure. I work out the relative atomic mass. That's 12, that's 1, and that's 16. I know those. And then what I do is I divide these. Right, I divide these 2 numbers. If I lay it out like this, it's easy. So we look at the number of moles, and then we look at the simplest ratio, yeah? Right, so if I did that divided by that, I should get about 4.4, 11.1, and 1.1. Now look, 1.1 is the smallest one, so I'm going to divide everything by 1.1, divide by 1.1, divide by 1.1, and I get here, I'll get 4, 10, 1 in that sort of ratio, yeah, roughly. So you can round them off to that. So my formula will be C4H10S. I don't need to write the 1. Right, now what they're saying is the relative formula mass is 90. This is 1 unit of it. So I'm going to go over here. I'm going to say carbon equals 12. And I've got 4 of those. I've got hydrogen and I've got 10 of those. 1 times 1. 1 times 1. 1 times 10, which is 10. And then I've got sulfur. Sulfur is, what was this? 32. Let me just check. It's 32, so you've got 32 times, there's only 1, so that's 32. If I add all these together, I get 48, 58, 68, 78, 88, 89, and 90. Now, because these two numbers are the same, I know if I did this 90 divided by that number, I get 1. Don't worry about this, it'll come up again anyway. So my molecular formula is C4, it doesn't change. Right. Right, okay, let's get through this. We can make the video nice size. So now look at this, that's just sort of like a typo. So you end up with this. Remember I said to you about ethene, it's really important. It comes up so much. Remember you do and these bars, they cross it, and you put a little N there. So you had lots of ethenes, and it became polythene or polyethene. Right, what type of reaction this is? It's addition, because you only end up with one product. You only end up with one product, yeah. So just remember, when you've got addition, you only get one product, and in this case, it's polyethene. What's the description of a molecule? Monomer, a molecule used to make a polymer. Yeah, simple. That's not true. That's not true. What's the name of this compound? It's got a double bond, and it's got 1, 2, 3 carbons. So it's monkeys eat peanut butter. Monkeys eat peanut. So it's propene. Draw the structure of the repeat unit. So this is what the repeat unit will look like. Again, this has come up a few times, so why not learn it? So remember what's happened. Let me go back. Get rid of these. So if you have to draw a repeat unit, this is the original. It's a double bond. What we're going to do is we're going to delete this. Right, one of the bonds we're going to delete, and then we're going to extend it that way and that way. That's the repeat unit of the polymer. Right, draw the displayed. Right, this is a tough one. So if you notice, you've got this, it's repeated. So we need to draw this somehow, yeah? So we need to do C, C, H. Oh, no, Cl. Chlorine. You've got hydrogen, and you've got these two bonds out there. What happens, we're doing it in reverse now. These two bonds cross out. They end up there. Let's get rid of these two to stop confusion. That is that's the one we want drawn here. What does the word biodegrade mean? What did we say? We said it is not broken down by what? Bacteria or microorganisms. What makes these polymers not biodegrade is that they are inert. Right, that's it. We'll come back to this one then. Inshallah.